Okay, first off, our denominator looks like it's already factored. Okay, so that's good. So our numerator, is there a greatest common factor? No, okay, no greatest common factor. So we need to try to split it up. Is our first term and our last term, are those both perfect squares? X to the fourth and 16y to the fourth. Are those both perfect squares? Yeah. Yeah, so that means we can do the difference of squares. Okay, so what would the first two terms have to be to give us an x to the fourth? X squared, yep. Now, since it's a difference of squares, one will be plus, one will be minus. What do the last two terms have to be to give us the 16y to the fourth? 4 and what else? Y squared, yep. Okay, at this stage, can we cancel anything?
Yeah, you can cancel the numerator and denominator.
Which part of the numerator and the denominator? The far left. So the x squared plus 4y squareds were identical, so we could certainly cancel those. Okay. Look at this remaining factor here of x squared minus 4y squared. Can we factor that one again? Yep, it's another perfect square, so we can factor that one again. Ooh, that looks a little funny. Take 2. So we know our first terms here would have to be x. Once again, we see it's a difference of squares, so one will be plus, one will be minus. 4y squared. How will that factor? To 2y and 2y, yep. And then our denominator, we still have an x minus 2y left. So now is there anything in common? The x minus 2y's are in common, so what are we left with for this one? Yep, and x plus 2y. Is that one okay? All right. And the very last problem, x squared plus 1 all over x plus 1. Is there a greatest common factor in the numerator or in the denominator? No. Okay, so now we need to see if we can factor it. So the denominator, does that look like it's already as simplified as we can go? Okay, so numerator, x squared plus 1. Okay, well, if we put x and x here, our last terms would have to be 1 and 1, right? What's the only way how we can end up having the outside and the inside cancel? Because there's no middle term f. If one is positive and one is negative, right? But that means our last terms would have to be a minus 1. What's the last term here? Plus 1. So can we factor that numerator? So that's simplified. Recall that we can only do a difference of squares. We can never do a sum of squares. Okay, so if we have the plus sign in between those two perfect squares, there's nothing we can do about it. Does this make sense? Okay, it's a lot of factoring. You're going to get, hopefully you're going to get very good at it.